I will start my presentation about how big is the risk when using LLM, when creating source code, especially focus on source code. But we are going to shed light on license compliance and copyright infringement. I am not a specialist for copyrights or license compliance. I just only do detection. And that's, as Massimo said in the previous talk, it's all about you and how you interpret the copyright infringement or not. So we are going to focus on just only on plagiarism. I will talk about what are we going to do. What are we going to say today? Well, I will present myself. I will do it just now. But then I will cover why we think this research is relevant. We will mention some few previous research, and then we will go through our experiment. It was a very short experiment, but with concrete results. And then, well, maybe we can discuss, we can open for a few questions. I would like to know your feedback. And then, well, I will tell you some next steps that we are planning to take in this direction. So first of all, I will introduce myself. My name is Oscar Goñi. I'm from Argentina. I'm a system engineer. I hold a degree on computer science. I am a professor at the university. I have been working for 20 years on the university. And also I am part of the Software Transparency Foundation, who is behind of this investigation, and one of the most interested part of this investigation. So let's start by mentioning why do we think this investigation is important. I think that Massimo talks us some things in the previous talk about what's happening when we often hear some music that sounds familiar. So in many cases that we say, oh no, it can be because the music is new. But in many cases we are not so wrong. Ed Sheeran is one of the most known cases where with the legal issues, and on the other side we have Dua Lipa. We have covered featured a lot of hits and create an album from a lot of hits. But in that case, in Dua Lipa's case, there's no license, no copyright infringement, because all the author has been credited in the right way. So the software industry has been suffering for this for many years, and in the past years, this has been increment. Well, there's an increment with the adoption, particularly with the adoption of the code generation. So let's see what happens in a realistic scenario. Well, a developer writes a prompt to solve a specific technical challenge, and so ask an LLM to write a source code. Then he gets back the code, and then, well, he's happy. So in the best case scenario, he has well, the code is functional. We are not going to talk about functionality or vulnerabilities or something like that. But right now, the code has no strong similarities with an existing source code. So he has not to worry about license compliance or copyright infringement. So, well, he's happy. But if the code has strong similarities with a real code, with an existing code, well, that could be a problem, because he could be falling in the infringement of some copyrights. So consider that LLMs have been trained with open source code bases. So it could be possible that this scenario could happen, that the generated code could have original code, so open source code. So if it has a strong similarity, well, this is where the ghost of plagiarism appears. So, okay, LLMs have revealed the way we build software today. But now we have some problems. So this kind of problems, or this kind of concerns, usually reach the STF Foundation with, well, in this case, well, scanoss, a strategic member of the Software Transparency Foundation, trusts us with a clear and urgent mission, that it was to, okay, the service provided by the foundation is able to detect this kind of scenarios to the point that the source code generated by AI could be perceived as a plagiarism, and if yes, how much of the code that the LLMs that are running on workflows today are creating source code that overlaps existing OSS code. Sorry. And if it does happen, what happens when the code is not just similar, it's just a verbatim copy? Consider the case that the LLM has generated a verbatim copy of the source code that we have in some repo. And what are the implications for the company that ships that code and the rest of the code base? So after a long discussion, we agreed that checking the similarity on the source code is just the first step towards understand the true scale of the problem. So it's just not about just finding small pieces of code that could be shared between the generated code and an original code. It's just measure the exposure of this code, quantify the risk that we can have if we introduce our some non-credited code into our source base, and lay the risk for lay the foundation for creating source code in a responsible way using AI. So that's where my journey begins. I wrote a small snippet with a clear definition and a clear task. It was to write a winnowing algorithm, a C implementation of the winnowing algorithm. This was in 2023. I asked to the LLM to create this code, and you can see here is a near verbatim copy of the scanoss winnowing algorithm. It was a very familiar melody for us. So this is the detection mechanism that the STF Foundation used for matching snippets. So what's happened in these cases? So we continue on the research. We found in 2024 a work revealed that after training a large language model with a substantial set of source code, about 1 terabyte. So after training and upon request, when the LLM is asked to generate the code, is produce a non-negligible amount of the original code used for the training. So then, that's where we decide to launch a large-scale experiment. So we propose two main goals. The first one is to reproduce the results of the original work. But especially what we like to do, we would like to know if what happens if we try to find this generated code in a considerably larger set of source codes. I mean, the original works search for similarities in 1 terabyte approximately of source code. The STF KB is about 27 terabytes. So what's happened in those scenarios? And as a secondary objective, we would like to know if the winnowing algorithms, we want to assess if the winnowing algorithms is suitable for this kind of scenarios, for finding similarities. So, well, our first hypothesis is that those results could be a bit more, not only the 3%, between 0.3 and 3% that the original authors showed. We think that this it should be a bit more, and we place this number as a lower bound. So, but we think that from statistical synthesis to coincidence or some structural coincidence, this number could be, well, it's greater. So what would that mean? That means that the developer could be laying in the sand and thinking that the generated code could have at least 3%, 3% of the original code. But in fact, the LLM has reproduced a large segment of source code. So in this case, well, it could have a a lot of problems with the copyrights and compliance requirements. So this is about our setup, what we use in our experiments. Sorry. First of all, we have the KB. Is the OSS KB. Well, database is basically maintained by scanoss, and a strategic member. The winnowing algorithm is for the snippet detection. I will talk about it next. Then we have the scanoss.py tool. That's also is a tool for scanning through the OSSKB service that query or fetch data from the OSSKB. And the important thing of this experiment of this setup is that everything is open source. The KB, all the software, the service is completely free. You can access through an open API. So this is everything. Everybody can do it. And if you want to check if your code has similarity, you can hit the service and get the results. Finally, I applied a small script to define the result, but this is a very small part of the experiment. So, well, let me show you briefly how it works, the winnowing algorithms. I know that many of you already know it, but it's basically it's an algorithm that it's basically used for document comparison. What it is basically, well, the scanoss has made slightly modification for the detection and focus on open source. What it does, the algorithm, well, after a very simple normalization that removes, but only keeps numbers and characters. Well, after this, what we does is start computing hashing on a sliding window, and then only keep the hashes, and finally, well, on that windows, inside that window, well, it's taking with some selection mechanism, it gets only one. It keeps only one hash. So in this case, the window, you can see that the mechanism is quite simple, and then the similarity search is just finding consecutive, a list of consecutive matches or hashes. So in this way, the code is completely confidential. You are not sending your code to the service. You're only sending hashes of the code, and the service returns back the match, if the potential match. The service also includes the snippet line range and also the source of the snippet. Well, what we find? Well, the first result was not particularly encouraging. We start receiving a lot of matches, but we have to consider some scenarios where, for example, we have some false, what we call false positive, is just a consecutive list of matches, but in fact, the code does not have a structural similarity with the real one. So we need to find out some mechanism to remove those. And in another case, we found similarities, but you can see that those similarities are related to, open or close brackets and something like that. So then we decide to move forward and go through the same metrics of the original study. The original study have used several metrics based on distance basis. So for this, we need to collect all the potential experiential source code. I mean, the Winnowing algorithm does not need the remote source code, the original source code. But in the case of the original study, yeah, they do need the original source code. So we need to we downloaded all the files, or we get all the files, and then we do the calculus of those metrics. Well, we also find that as those metrics are distance based, and when we have on the remote file that we have on the original file is a complete file, and sometimes what we have with the LLM is just a snippet of the code. When we calculate the distance between one piece of code and a big piece of code, well, the value is dilutes, the score dilutes. So what we develop is just a simple metric that we call WMMR, Winnowing matching ratio. What it does basically is just to measure the density of the amount of snippets that we have in a line range. So with that value, what we does, this value led us to focus on a simple region of the source file, on the original file. So in this case, we see that what we are doing is shifting the comparison to a exact part of the source code where the potential match occurs. So those are the metrics for the original study. The green one is the Winnowing matching ratio. You can see that the behavior is almost the same, and what we get is just a bit more of increase in the percentage. But we also, so the first hypothesis, we can prove this. We are what we thought that it could be increased. Yes, it's fine. And also we check that the Winnowing matching ratio behaves good for this kind of situation. So, but the good thing for this new metric that we have introduced is that we do not need the original source code to check if the similarity is real. So what would that mean? Well, the similar is real. We know it. We find it, but the developer can argue, well, there's no different way to do this. This the only one way to implement this piece of code or my intention of code. Or maybe it's just coincidence, or that the LLM have used the same variable names or the method names or function names. Or this is just a suggested implementation in case we are using some dependency. Okay, this is the implementation. The LLM has used the same code. But we can say, okay, this is fine. The similarity is so real, so we should check that we can have some problems. So what we should do? If we check that we find similarities, the first thing we should do is to check the source. Okay, I go to the file, the path where the similarity occurs, and check if it is real or not. It could be automatically done, but we can check it. If it yes, we should do a proper author attribution. We should do it. We should not skip it. And then check the license assessment. If the license that I am releasing my product is compatible with the one of the original source. And then, well, let's the expert to do the license compliance work. So after 2 researches, using different KBs and methods, but reaching similar results, we need more research to prove that this risk of plagiarism could exist. What else? Well, what about, okay, this could not happen if I'm coding every day on my computer, but what's happening if everybody on my organization is using AI tools to generate code? How many code will be new and how many is reduced from the training data set? What about if I'm doing, working or developing just a product for myself, or I'm planning to sell it and need more work on the compliance side? Oh, and finally, is the risk small enough to ignore it? Which is the risk if I compare it to the benefits of using AI generators? So basically, what we think is, can we do without snippet matching, or can we live without testing if our code is original, or if our generated code is original, or it's just a part of some original product? So what it seems to, well, what it was a recommendation in some years ago, now should be a systematic practice. So in those cases where the plagiarism I would like to know your feedback about this. If the plagiarism is a risk, as I said before, which is if we compare with the benefits that that using those generators give us, and how do I should manage this risk? Should I periodically do scans and then check if the file is original, or if it is cloned from some other repo? And you, as software development, what do you think, or how could you feel if you know that an LLM is creating source code based on your repos, on your source code? I know that it is open source, but let me go back just a little. But I just strike the my, because I have the experience some days ago that when I start creating some source code, the copyright started appearing co-authored by Cloud. So in this case, we are two generating the code. So what would happen in the future? This code will be mine, or will be co-authored with Cloud. To finalize, I would like to tell you the next steps we are planning. We are completely sure that we should continue working on the detection mechanism. We should improve in it. We know that we are missing some cases, in particular where the variable names well, the variables are renamed, and we want to make some. We are working with this, and we are getting good results, but this is for the next event. And what about the structural? What about the intention? If we could extract the intention from the source code and then hash the intention of the source code instead of hashing or comparing the text source code. And I would like to know what's happened with with those results when we start applying modification to the prompt. I mean, what's happening with that value if we start adding modification? Should we receive more matches? This number will be increased, or we should, or in this case, the AI will stop reasoning in such a way that that number decreases to 0. Question? Oh, yeah. Let's start.
Have you tried comparing human-generated code to human-generated code to see what the overlap is?
For example, but you mean that a kind of experiment?
Yeah, it's the same way you did synthetic code against human-generated code. Did you try doing a control of human-generated code against human-generated code? How often do people, by probably coincidence, generate the same code?
Oh no, that's a very nice experience. It's a kind of related, more social related, I think, because that's a very, very nice experiment. Because
it can give some insights into the level of the problem Gen AI creates, right? Because maybe it's the same.
If we actually find the number to be 5%, that humans are probably 5%.
Exactly.
AI is not at fault.
Exactly. Yes, exactly. Yeah, this problem, as I said before, this problem has been for several years. Yes, please.
I understand that code which is replicated because it's learned upon and it has some sort of license could be a problem. But as you stated, many of the things, it's just the way it's done, right? This is how we write those pieces of code. So maybe it's more about the code which is really IP trademarked or where there's real IP intellect pushed upon. Or from the source code, it's IP code, right? Or trademark or patented code.
Yeah, it could be, but yeah. Yeah, actually.
And in that case, if you come there with your own research without actually doing plagiarism, you just receive, you have the same problem when you do it by hand and when the computer.
Exactly. The problem is the same. Just that right now it's speeding up the problem. Basically,
no, exactly.
That's.
And my final thing. But I like the automatic way of searching for it. But if I create proprietary code and it runs inside my business, no one will ever see it. There is no one who can see my code. Of course, we're at the open source side.
Yeah, in the best case.
Governments should open source their code. But
yeah, in the best case, yeah. Yeah, we usually find proprietary code inside the open data sets. Yeah. Yeah. Yes.
We've correctly identified that Winnowing. We identified that Winnowing fingerprinting is not good in the case of renaming functions, renaming variables, etc. What other similarity algorithms are you going to apply to your research?
I think that.
And the second question, if when you do that implementation, are you going to open source it with scanoss?
Sorry?
So when you have that implementation, will you open source it and apply to scanoss?
Yeah, I will share the links at the end, but all the sources are open. You can create your own database, and you can.
First question is,
yes.
which other similarity algorithms
Okay. Yeah, I think that what we are doing right now, and we are getting better results, is just to modifying the normalization. Modifying the, yeah. I showed here. This is the normalization. We are keeping only alphanumeric characters. What we are doing right now is just changing the way we normalize the text. So in those cases, for example, we are removing function names or variable names and replacing it with some kind of identifier. And then we run the same algorithm with this kind of modification.
About perhaps using something like cosine similarity or something like that that we use like in RAG pipelines to identify the similarity between the output and the ground truth that we use for RAGs.
Yeah, the thing is that algorithm is pretty.
It will increase your detection data set. So from 27 terabytes, it probably go into a couple of hundred when you
Yeah.
create embeddings for the entire database, but it will give you a slightly better result.
Yes, of course.